2.4, which is slope-intercept form of a line. Slope-intercept form is exactly what it sounds like. We have this slope, m, and the y-intercept, b, equally visible in this type of line. So if we see right here, the dot, or the place where x equals 0 and y equals some number, that would be b in this case. So in this case, b would be -1. Because that is the point where the line crosses the x-axis, crosses the y-axis. Now we can try and find the slope. We would do that by finding a change or difference between two lines or 2 points on the line. So between the points -2, 3 and -1, 1, we have a delta x, or change in x, of -2 minus -1. So that would be a change in x of -1 minus -2. So that would just be +1 because we've gone 1 forward. And then here we've gone, when that happens, y, it went down by -2. So we have a slope of -2 over 1, which is just -2. So for this line, we have y equals -2x minus 1, because that's b. And so we know, we can check this by plugging in points. So we know that 1, -3 is a point. And so if we plug that in, we get -2 times 1, which is -2 minus 1 equals -3, so this works. Now we can try this again for this line here. So we know we have the point 0, 0, which is definitively on the line, and the point 3, 3, which is on the line. So we can see that x has gone up by 3 over this interval, and y has gone up by 3. Since m is delta y over delta x, that's 3 over 3, which is just 1. And we can visibly see that the x-axis, that the y-axis is crossed at the y value of 0. So the y-intercept is 0 at that point. So y equals x plus 0, or just x. Y equals x. And we can see that here because every point is equal to the other coordinates. So -1, -1, -2, -2, -3, -3, 1, 1, 2, 2, 3, 3, and 0, 0. Now let's try and do this from a table. So -2 minus -3, 1, we increased by 1. -1 minus -2, we increased by 1 again because -2 and -1 are 1 apart. This time we increased by 3 because -1 and 2 are 3 apart. Then we increased by 1. And then we increased by 4. Now let's see what's going on the other side. When y increased by 1, x increased by 3, increased by 3 again when it increased by 1. It increased by 9 when it increased by 3. Increased by 3 when it increased by 1. And it increased by 12 when it increased by 4. So, we can see that that 3 times y equals x just by looking at these, because x changes by 3 times y is changing, and we can simplify to y equals 1/3 x. Now we can plug 2 points in here to see if this is correct. So, or to find out what b is. So, oh, and that subscript right there just means the b's are different types of b's, because we would have to divide by 3 the whole time, and we're not going to do b over 1/3. We're just going to do b, because it's an arbitrary constant both times. So let's try plugging in the point 3, 10. So 10 equals 1. Wait, it would be 10/3 because. So so 3 equals 10/3 plus b, and 10/3 equals 3 and negative 1/3, so b equals negative 1/3. So let's plug in some more points, because right now we think we have 1/3 x minus 1/3, but we have to check. Let's plug negative 8 in. So minus 8/3 minus 1/3 is minus 9/3, which y equals negative 3. That's correct. Minus 5/3 minus 1/3 is minus 6/3, which is negative 2. 22/3 minus 1/3 is 7, so it looks like we got that one right.